So let's start the chapter by looking at how to find the value of a symbol, an unknown, that is the symbol here, when it's expressed in an equation where something on one side of an equal sign equals something on the other in the equation. So we're going to look to solve the equation if we can find the value of the triangle here. So when we're looking to find the value of an unknown, we always move towards isolating that symbol, i.e. keep that symbol on one side of the equal sign and move all other parts of the equation over to the other side. So in this case, if we have a triangle plus 3 equals 5, we keep the triangle to the left, we write down our equal sign, and we bring over the plus 3 over the equal sign or over the bridge, and its sign changes to minus 3. And that means that the value of the triangle then is equal to 5 minus 3, it's equal to 2. And we can check that by putting the 2 back in here, where we see the triangle. If the triangle is equal to 2, we can say 2 plus 3 is equal to 5, and that is true. But be careful again, because you might have something like 3 plus an unknown symbol is equal to 6. So it's the same procedure again. We isolate our symbol, leave it to one side of the equal sign, and we bring our plus 3 over, and its sign changes to minus 3, which means that our symbol is equal to 6 minus 3. Our symbol value, the triangle value, must be equal to 3. And this is one that will occur over and over in algebra, or at least every now and again. You really have to take care of this. If you're looking to solve an equation like 15 minus an unknown symbol is equal to 7, then carry on as normal. Isolate your unknown symbol, but keep its sign. Remember, this is the symbol and its sign. This is plus 15, this is plus 7. So minus the symbol, isolate it on one side, is equal to the 7, and we bring our 15 over, it becomes minus 15. So minus the symbol is equal to minus 8. But we're not looking to find the value of minus the symbol or the triangle. We want to find the value of the triangle, the positive value, not the negative value. So if we end up in a situation where we have something like our minus the symbol we're looking for is equal to a number, in this case it's minus 8, then we can find the value of the symbol itself, the positive value of the symbol, by just simply multiplying both sides of the equation by minus 1. So this is a rule in algebra that we can use every time, whereby we multiply the minus symbol sign by the minus 1, and we multiply our minus 8 by minus 1 as well. And we know from multiplying integers, positive, negative, or multiplying integers, that like signs, minus by minus gives plus, which is what we want, and 1 by our symbol is the symbol, and minus by minus gives plus here, and 1 by 8 is 8. So in fact, our symbol is equal to 8. And again, if we put that back into our original equation, 15 minus 8 is equal to 7. We've solved the equation. Now we'll just move on, and we'll take a look at how we, in algebra, how we stop using or we lose the multiplication and the division symbols. Okay, so something in algebra like 2 multiplied by a simply becomes, or looks like, or is written as 2a. And something which is written in algebra as 2 divided by k, well, we lose the division sign and we simply write that as 2 over k. So if we look at this problem here where we have 4 times the triangle here is equal to 20, well, that's the same as saying 4 triangles equals 20, and that means that the triangle must be equal to 20 divided by 4. The triangle is equal to 5. And similarly here, if we're looking to find the triangle, finds triangle if this triangle divided by 3 is equal to 6, then the triangle is equal to 3 times 6. The triangle must be equal to 18. And if we were to plug that back in here, 18 divided by 3 is equal to 6. And so let's take a bit of care here now when we look at, in algebra, multiplying, or are we adding stroke subtracting. So 2 times a, 2 multiplied by a is 2a. A multiplied by b can be simply written as ab. 2 multiplied by a multiplied by b is written as 2ab. If you notice, what we're actually doing is we're writing what we see. We write the 2 and we write the a. We write the a and we write the b. We write the 2, we write the a, and we write the b. What's interesting is when we have to multiply something like 4 multiplied by a, multiplied by b, multiplied by 2. So we have two numbers in this expression. Well, we can actually multiply the numbers out. We don't write 4 by 2, by a, by b. We multiply 4 by 2 to give us 8. And then we write down our a and our b. So 4 times a times b times 2 is equal to 8ab. And if we look to add and subtract then, in this case 2 plus a is simply 2 plus a. You can't do any more with that there. They are not like terms, okay? A plus b is simply a plus b. A plus a. Now a and a are both like terms. They're the same letter. They're to the same power of 1 here, which we never write and you don't see. But because they're like terms, we can actually add the two a's to give us 2a. Or here we've 2 plus a plus b. Well, that's simply 2 plus a plus b, because they're all different terms. We cannot actually add them up together. And here we've 4 plus a plus b plus 2. Well, in this case, the 4 and the 2, yes, they can add up to 6, but we are still left with plus a plus b. Let's look at this problem here. If symbol plus symbol plus symbol equals 30, find the value of the symbol. Well, the symbol is the same. There are 3 like terms, so we can add them up. That gives us 3 symbols on the left-hand side of the equation is equal to 30. So one symbol must be equal to 30 divided by 3, and that's equal to 10. And indeed, 10 plus 10 plus 10 is equal to 30. Some algebra problems will give you values for the symbols. You might have a dot that's worth 5 and a triangle that has a value of 3, and you might be asked to find the dot plus the triangle. Well, that's 5 plus 3, that's 8. Or the dot multiplied by the triangle, that's 5 times 3, and that's 15. Or the dot plus 2 times the triangle, so that's 5 plus 5 plus 2 times 3 is 10 plus 6 is 16. Simply substitute in the values and calculate. Let's look at some of the language and terminology that we use in algebra. So let's look at this expression here, 3x plus 4y plus 4. This is known as an algebraic expression, and it has 3 terms, plus 3x, plus 4y, and plus 4. Always the number beside the x and the y variables, they're known as the coefficient. The x and the y, the values of these can change from some to some in different problems as you work through algebra, so these are just known as variables. And the number at the end of the algebraic expression, if there is one, this number is not a variable and is therefore known as a constant. Okay? And in algebra, we have algebraic expressions like this with terms, and sometimes we might have terms like 3x and 4x, which we would call like terms because they have the same letter, x, and that letter x is to the same power, in this case of 1. We can add and subtract, and we can multiply like terms. However, terms like 3x and 4y are not like terms, okay? Because the letters for a start are different. So they're not like terms, and we cannot add them, but we can multiply them. So you just have to be careful there, okay? We can add and subtract and multiply like terms, and we can multiply unlike terms, but we cannot add or subtract unlike terms, okay? So 3x plus 2x is 5x, whereas 2x plus 2y is still and always will be 2x plus 2y. In algebra, we're asked to simplify terms, and how do we simplify terms? Well, we gather first and then we add any like terms. So if we're asked to simplify something like 3a plus 4b minus a plus 2b plus 2a. This is an algebraic expression with 1, 2, 3, 4, 5, 6 terms. Okay? Now, I didn't use the word algebraic equation because there's no equal sign in this term. It's an algebraic expression. Anyway, to simplify the term, we gather the like terms. To simplify this expression, we gather the like terms. So we get all our a's. So we've 3a, and we've minus a, and we've plus 2a. And when we're finished with the a's, we then go back and we look at 4b, and we look for any more b's, and there's a plus 2b there. And 3a minus a is 2a, plus 2a is 4a, and 4b plus 2b is 6b. And 4a plus 6b is the simplified expression of this algebraic expression here. In other words, that's our answer. Sometimes in algebra we're asked to simplify expressions, but within those expressions we have some terms that are contained within brackets, and we have to remove the brackets. So to simplify something like 3 times x plus 5, which is what that actually is, we have to multiply the outside term by each of the inside terms. So 3 by x is 3x, and 3 times 5 is 15. Or in this case here, if we were to simplify this expression here, 4 by 2x. Well, the 4 and the 2, remember from before, we can multiply those two. That gives us 8x. We're multiplying our numbers to get the 8, and we're writing what we see. Okay? And 4 by 6 is 24. And these can get a bit more complicated in that we might be asked to simplify something a bit longer, like this one, where we have 6 by 2x is 12x, plus 6 by 3 is 18. And then we've minus 5 by plus 3x is minus 15x. And we've minus 5 by plus 2. Well, the minus by the plus gives minus, and the 5 by 2 gives 10. So always remember that, you're multiplying your sign by your sign and your expression by your expression. Your sign by your sign and your expression by your expression. Your sign by your sign and your expression by your expression. Sign by your sign, expression by expression. So once we have achieved this line here, we need to gather and simplify. So we start with the first term, we say 12x, we look for other x terms, minus 15x, anymore? No. Then we see what the next term is. It's plus 18. It's a numerical value. So we look for more numerical values, minus 10. So 12x minus 15x is minus 3x, and plus 18 minus 10 is plus 8. Let's look at multiplying like terms. Well, we all know that 5 times 5 is 25. But another way of writing 25, or 5 times 5, is 5 squared. Why is this? Well, this is because each of the 5's is to the power of 1. We don't write that all the time, but it's always there. And when we're multiplying like terms, a 5 is similar to a 5, then we can simply add the indices of the 5, which in each case is 1 plus 1. So 5 times 5, or 5 to the 1 times 5 to the 1, is the same as 5 to the 1 plus 1. 5 to the 1 plus 1. And that's equal to 5 squared, which is equal to 25. Similarly, or also, a to the 1 by a to the 1 is a squared. A squared, if we happen to come across that, times a squared is a to the power of 4, because that's the same as a to the 2 plus 2, which is a to the 4. Or 2a times a, well, 2 times 1 is 2, and a times a is a to the 1 by a to the 1 is a squared. So 2a by a is 2a squared. 3a times 2a, you multiply, well, if there were signs, oh, there are signs, sorry, you can't see them, but sign by sign, positive by positive is positive. It's not written there, but it's there. 3 by 2 is 6, and a by a is a squared. So 3a times 2a is 6a squared. 5y times 10y is 5 tens or 50. Y by y is y squared, 50y squared. Let's look at two ways to multiplying two expressions that are contained within brackets. So the old way, the way it used to be done, to multiply x plus 2 by x plus 2, we used to say x times x is x squared, plus by plus is plus, x by 2 is 2x, plus by plus is plus, 2 by x is 2x, and plus by plus is plus, 2 by 2 is 4. And so we would gather the like terms, so we'd have x squared, there's no more x. So we gather the terms, we have x squared, 2x plus 2x plus 4x, they're like terms, the x to the 1. Notice how x squared is not a similar term to x, or x to the 1, and then we have plus 4. And a newer way to multiply two expressions is simply to take the first term of the first expression and write it here, and then write the second expression beside it, take the sign here and write it there, and take the second term of the first expression and write it here, and write the other expression beside that again, and then multiply out. So positive by positive is positive, x by x is x squared, plus by plus is plus, x by 2 is 2x, plus by plus is plus, 3 by x is 3x, and plus by plus is plus, and 3 by 2 is 6. So we gather our terms here now. We have x squared, there's no other x squared terms, so that's done. And then we have 2x anymore, yes, there's 3x, that's plus 5x, and then we have a 6 here, plus 6, no other terms, plus 6. So x plus 3 times x plus 2, when we multiply those two expressions together, we get x squared plus 5x plus 6. So just let's look at the new way again. If we're multiplying 2x plus 6 by 3x plus 2, we write the first term 2x here, we write this expression there, and then we have plus 6 here, and we write this expression again there. And then we multiply through. So plus by plus is plus, 2 by 3 is 6, x by x is x squared. We get 6x squared. Plus by plus is plus, 2 2s are 4x, plus by plus is plus, 6 by 3x is 18x, and then plus by plus is plus, and 6 2s are 12. Gather the like terms. We have 6x squared, 4x and 18x plus 22x plus 12. Or a third way to solve multiply two expressions together is to use the area method, where we write the expression 2x plus 6 along one side of our grid and 3x plus 2 along the other, and we multiply the terms. So 3x by 2x is 6x squared, and 3x by 6 is plus 18x, and 2 by 2x is plus 4x, and 2 by plus 6 is plus 12. So that would give us 6x squared plus 22x plus 12, which is the same answer as above, using the area method. We'll just finish now by looking at some final multiplication examples. Okay, so the first one here, 4 by a squared plus 2a minus 1 minus 2 by 2a squared minus 3a plus 4. So plus by plus is plus 4 by a squared, 4a squared, plus by plus is plus 8a, 4 by 2 is 8a, and then plus by minus is minus 4 by 1 is 4. Minus 2 by 2a squared, minus by plus is minus 4a squared, minus 2 by minus 3a, minus by minus is plus, and 2 by 3a is 6a, and minus 2 by plus 4, minus by plus is minus, 2 4s are 8. Notice how the minus sign outside the brackets changes the sign. All signs inside change when you multiply by the minus sign. The minus sign is like a switch. Try and remember that if you can, it's very important. So when you have your terms, then you gather 4a squared, any other a squared terms. Well, there's one there, so we have minus 4a squared. Then there's no more a squared terms. We look for a terms, plus 8a, any more, plus 6a. No more of those, minus 4 and minus 8. The 4a squared minus 4a squared, they cancel. 8a plus 6a is 14a, minus 4 minus 8 is minus 12. Okay. Now, let's look and recall this. Let's remind ourselves. A squared can be rewritten as a times a, and 5 squared even can be written as 5 times 5. X squared can be written as x by x. So it's logical to assume that something like an expression 3x minus 2y all squared can be written as 3x minus 2y times 3x minus 2y. Like a squared is a times a, 3x minus 2y squared is 3x minus 2y times 3x minus 2y. And then if we were to multiply that out, we would get 9x squared plus 4y squared. Simply by doing as we've always done, sign by sign and term by term. Sign by sign, term by term, sign by sign, term by term. And you'll notice here again that the plus 3x minus 2 times minus 2y times 3x becomes minus by plus is minus 2 3's are 6yx. So we're writing what we see. And minus by minus here becomes plus, and 2 by 2 is 4, and y by y is y squared. Okay. So just finally then, we just want to realize that a term like 8ab is the same or a like term to something like 4BA. Doesn't matter the order in which the A and the B are written in. They are like terms, these two terms. Okay? So where did we get these from? We got these from let's multiply this expression here, or let's simplify this expression. 2a minus 3b times 5a plus 4b. So we like to write it as 2a, and then we write this expression times this expression, minus 3a times this expression again. Okay? So 2a by 5a is 10a squared, 2a by 4b is 8ab. Remember, we multiply the numbers, we write the letters that we see. That's from the first slide. And then we've minus 3b times 5a. Well, that's minus by plus is minus 15ba. And then minus by plus is minus, and 3b by 4b, minus 12b squared. Okay? So let's gather the like terms. 10a squared plus 8ab minus 15ab. I've just rewritten that the other way around to show you that that's okay. Minus 12b squared. And the final gathering of these like terms then, of all the terms, is 10a squared plus 8ab minus 15ab is minus 7ab minus 12b squared.